observations.
Thanks, Paul. Yes. Our main news here today is that the universe really is accelerating. By using the Chandra X-Ray Observatory to study giant galaxy clusters, we've obtained strong new evidence for dark energy and clear and direct confirmation that the expansion of our universe is accelerating. Our results, which are completely independent from supernovae studies and are based on only very well understood, simple physics, provide important new clues about the nature of dark energy and show that it behaves much like the cosmological constant in Einstein's theory of general relativity. Too low. Conversely, if we were to assume that a cluster were further away than it really is, we'd sample in order of increasing distance. Our clusters span a redshift range of 0.1 to 0.9, corresponding to distances of between 1 and 10 billion light years. What we find is that the distances to the clusters are all significantly larger than they would be if there were no dark energy. And moreover, we find that the distances are growing ever more rapidly as we move towards the present day. Dark energy is pushing the universe apart and accelerating the expansion.
3/4 of our universe is dark energy, 4% is normal matter, and the remainder is dark matter. Now, perhaps the best way that we can find what dark energy is to see how it might change with time. And our observations are consistent with the cosmological constant. By constant here, we mean that the energy density of dark energy is constant with time. The data also allow for the density of dark energy to increase slowly into the future. It's unlikely it was larger in the past, otherwise the observed structures in the universe, indeed the clusters that we use, they would not have existed. They would not exist now.
In the future, or you just don't have the answers yet?
The most radical of those solutions, which was the big crunch that he talked about, and you might well visualize that as some kind of disaster for everything, but it's by no means certain or anywhere near that disaster is on the cards for us. As I say, at the moment our results are consistent with the cosmological constant as being a likely model for dark energy, and in that case that disaster wouldn't happen.
And it's at least 30 billion.
It's a long way away, that's
30
right.
billion years away.
Yeah.
One that comes into play if the dark energy density